Thanks, Kelly. You know, I don't. There's a way to start recording automatically when you start the meeting up, but often there's stuff I want to say that I don't want on record, and so I wait. For those of you just joining us, we're about a minute into this. We're just talking about what we were looking at on Tuesday, and I wanted to point out different kinds of styles of templating on the back end. So Pug, Jade, this is EJS we're going to see here. These are available really in any framework. Like you can use these in, I assume I can do Pug or Jade in Python. If not, there's something really, really similar for it. So if we look at the index EJS, so this corresponds to, this was the node side. Here's index.html. So like this is just straight up HTML, right? Oh, here's index.pug rather. So this would be the corresponding Pug version of what we're about to look at in EJS. Here's what it looks like in EJS. This one, same thing. It does exactly the same thing, but here I've got, you know, a paragraph, just a P here, welcome to title, and here it's the full HTML. Here's the title, welcome to, there's the full paragraph tag, and so on. EJS is embedded JavaScript, and it's a little closer to HTML. This style is just a shortcut. It's a way to write HTML without having to write all the stupid tags, because who wants to write P, NP, H1, end H1 all the time? Here we can just sort of notate them. The templating engine will spit out the HTML for us. It'll fill in all this stuff, put in all the tags for us. It spits out HTML, and that's what gets shipped back to the front end. You know, what you guys use, like, you're gonna have to do, well, actually, you're not going to do any templating on the back end for your projects, so it kind of doesn't matter. You'll just be sending data back and forth. For your demo, though, which is, I think, upcoming in half a week or so, for your project demos, your prototypes, you will use a template. Which one you use, like, who cares? It's up to you. A lot of people find this a little more intuitive because it looks like HTML. But like if you know HTML pretty well, then you can do something like this and save some keystrokes. All of these, by the way, at least on the node side, all of these templating languages allow you to run JavaScript within the template. So I could create, for example, I could do something like, you know, I can't remember how to do it. You know, like let A equal 5. You know, A++, and so on. Like you can do straight up JavaScript and use the results of the JavaScript code in your template. So the way this template is built is it runs through a JavaScript engine. So any JavaScript that you want to throw in there to do calculations or sorting or whatever, you can stick it in there. And that works on EJS or EJS style or this sort of shortcut style in Pug. Benjamin asked if we want to set up the front end now and skip the templating on the prototype. Is that okay? Yeah, I guess so. That's fine. I actually just recommended templates to make it easy, but if you have a front end rolling already, that's fine. Go ahead and use it. Let's get rid of that. And we don't need that anymore. And don't ask. Don't do that. All right, so we're going to move from the back end to the front end now. And let me just talk a little bit about front end stuff kind of in general. So the front end, there's no slides for this. So you have to just watch me, unfortunately. So, so on the front end, and by front end for these sorts of applications, we're usually talking a browser. On the front end, there's going to be JavaScript, end of story. The front end frameworks are all JavaScript with one exception, actually two exceptions that I know of. One exception is you can embed Java applets in a web page using, I was going to say Sun's JDK. Sun's not around anymore, but there's a way to take a Java applet and embed it in the HTML and run it as kind of a I can't recall what the file extension is, but it's embedded Java basically. It's about as performant as you might guess, meaning that it's wicked slow usually, because holy crow, you got to ship a whole bunch of bytes up to the browser. You got to run a JVM inside the browser. Like there's a lot of stuff going on there. So they tend to be a little slow. Although I remember when they first came out, when Sun demoed applets in a browser in Netscape, like we were just blown away because nobody had ever seen anything like that before. We just had straight HTML before that. So that's one exception. The other exception is you can actually write Python code and use Python on the front end. The caveat there is the Python gets, Python's an interpreted language, right? So the Python gets interpreted, it gets interpreted into JavaScript, and then the JavaScript runs in the browser. So you've got an extra step, an extra indirection there, where it looks like you're running Python, but really you're running JavaScript that's been converted from Python. What could go wrong, right? So again, that's just a really, really slow system because there's a lot of abstraction happening. Frankly, I don't recommend it at all. That's the sort of thing you show at a conference just to show you can do it and you're clever and maybe you'll get a job out of it. I would never touch Python on the front end, which leaves JavaScript. So that means that any front end code is going to be in JavaScript. And there's a whole bunch of ways to handle that. So early on, when we started writing JavaScript, I remember when JavaScript was released too, and we started writing in JS in the browser side, you can just write straight JavaScript code. The beauty of JavaScript in the front end is that there's a tight binding between the JavaScript objects and the browser's objects. There's something called the document object model, DOM, the DOM. The DOM is essentially everything on the page in kind of a tree sort of structure. So it starts at the page itself, the document, and then the document has, elements in it. It's got a head, it's got a paragraph. The paragraph has, sub pieces to it. So there's this big tree that's built of the document in the browser. You have access to that tree from JavaScript. So anything you want to touch on the page, like it's trivial to do. Let me just, can I bring this up really quickly? I probably even have some code. We do a fair amount of JavaScript in CS 101 back in the days when I did CS 101. Do something, what's in here? Test, do add, do subtract. I guess I can just show this to you. Maybe let's see if it runs. A lot of these are student code that I was debugging. Oh, that's beautiful. 4, 5, 4 plus. Clearly we didn't finish debugging that one. Adder. IDs, all sorts of, holy crow. Well, here's one. So here's a button on the page. Nice. We go carried away in CS 101. Click me, run away now. So what happened there? Yeah, Harrison, remember CS 101? Did you take that with me? What happened there was, yeah, 101 was a blast. Apparently I'm not teaching it anymore. We hired somebody to come and teach 101. I guess because they wanted me to teach 210 instead of 101. So that's what's happening now, which is fine, I guess. Although I did write the textbook for 101, so it's kind of a bummer that it's gonna be another textbook in there. What can you do? So what's happening here though? Here's the source. So here's this button, right? Button, on click, go pop an alert. That's a function called pop alert. Here's the function pop alert, and I'm passing in a message to alert. So just take that message and the alert pops the little alert box that says okay. The thing I want to point out here though is that on the front end, we're very, very event driven. like that front end page is just a browser page, right? Like this button over here, this click me button. I can't really predict when anyone's going to click that button. I can't predict when they're going to scroll or fill in a form or hit submit on something or hover. Like I just can't predict anything, like when it's going to happen. And so the code that we write on the front end is very reactive. That's why we have React coming out of Facebook. You know, it's like we react to an event that occurs on the browser. There's a whole system of signals that gets passed back and forth kind of under the hood. We don't really see them. It's an event handler kind of system, which means that we write this code very, I was going to say functionally, but it's not really functionally. It's like handling interrupts. I've got a little piece of code that maps onto this event. I've got another little piece of code that maps onto this event, that sort of thing. So if I wanted to, another button with another function, I'd have to write a button with a function on click with an on click property. And you can see some of the, if I just do on here, these are some of the events that we can capture on the front end. So on change, on double click, when somebody drags, drag start and end, drag over something, like drag, an item over something else, on input, on load, key up, key down, mouse up, mouse down. They're all these things. These are all actions that a user or the code might take. Some data might arrive from the back end. Well, I've got to handle that data coming in from the back end. But these are all events. And I can attach a function to every single one of these events. From those functions, from those functions, we have control over everything on the page. So let's do a quick one here. I'll just add another button. Button on, we'll do an on click. On click equals change head, we'll call it. So I'm going to run a function called change head when somebody clicks it. Like that. This is brackets, by the way, we're playing in, BRACKETS, brackets. It's a free WYSIWYG code editor. Actually, for a lot of languages, we use it a lot when we're doing like just quick prototyping in HTML, because you can see what's changing on the page as you type it. It's kind of nice. Let's add a function. That function was called change head, right? So copy that, stick it up here. And for this one, let's find document. So that this tree starts at the document level, and each of these things has an ID. Actually, this one doesn't. Let me give it an ID. ID equals head. Let's call it head. I'm going to use that ID here. So a document dot get element by ID. If each element has a unique ID, I can go find that specific element in the tree. And then I can do things like just change it, like change its inner HTML maybe. Form of ID dot, can I do inner HTML? Yeah, maybe. Let's see if that works. And then that's the end of that function. Save and see if it works. So change head, when we click change head, when we click change head, nothing changes. Who knows why? But that's the idea. I can get to stuff. I can get to that inner HTML on this head. I can change, a paragraph. Actually, changing paragraphs is easier than changing a head. Let's start paragraph down here. And we'll give it an ID. Oh, here's why it didn't change. We didn't tell it which thing we wanted. It's head. Let's see if that works. There we go. I just didn't give it the ID. The ID is head. Here's the ID head down here. So just by responding to that action on the page, that event, that click of a button, I can modify what the page looks like. I can change its text, its color, positioning. You basically have control of everything on the page from JavaScript. And that's true of all of these front-end frameworks. All they really do is react to some event, run a function against that event, and then modify the DOM in some way, the DOM meaning the document object model, to make the page look different. So imagine, I've got a stock quote page and I've got data coming in periodically with new stock quotes. I don't have to like put a timer or anything in or a loop waiting for that new data to occur, to show up. All you really have to do is write a function that maps onto the onDataArrive event. And when data does show up from somewhere, like a backend from or something, I run that function that's mapped onto that event. I get the new quote and then just update the page with that new quote. So another really huge advantage of this kind of architecture is that on the front end here, if my backend server is rendering pages, so it's creating HTML and then sending the HTML to the front end to view, every time I do something, I'm getting essentially a new HTML page from the back end when I'm rendering. The page is going to refresh. So if you're on a slow connection, especially, you're going to get kind of a blank screen, and then it'll, it's like going to a new page on the web. It'll refresh. In the the JavaScript frameworks for the front end, that's not necessarily the case. So these are called single page applications. Let's stick it over here. Single page apps, SPAs. And it literally is you have one page, and then in reaction to events, to data changing, to user interaction, you just change the model. You don't refresh the page at all. So in these applications, you send one page to the front end, and that's it. Everything else coming from backends is just data. When the data changes, I update the page, but I can just update that little piece. I don't have to update everything. So there's no page refresh. It's a lot more performant because I'm not sending a bunch of superfluous HTML. I'm just sending or receiving that tiny piece of data that I'm interested in and then updating it. Here's brackets. Brackets.io is where to get brackets if you're interested in it. That's an Adobe product, a free Adobe product, an open source Adobe product. All right, so I wanted to show you Angular, a little bit of Angular. And I apologize, I keep talking about JavaScript. Angular is actually written in a different language called TypeScript. TypeScript is a superset of JavaScript. It's TypeScript. TypeScript is a superset of JavaScript, so it does everything JavaScript does. And then free Adobe product sounds like, no kidding. Karen, that's exactly right. I always forget that Adobe isn't an Apple company. Like I just because of that aesthetic, right? They just look very Apple-ish to me. It was funny is one application I used to use tons of called not FrameMaker. The devil was it called? FileMaker. FileMaker Pro, which also is very it's a really cool like drag and drop WYSIWYG kind of database application. I used to build tons of little databases out of FileMaker. That actually is an Apple company. It's like, who knew? And I didn't know that. Anyway, sorry about my confusions. Oh yeah, so this is written in TypeScript, which is a superset of JavaScript. It fixes JavaScript's problems, or at least the big ones. One of the big ones was that JavaScript doesn't have any type information. And so it's really easy to screw stuff up when you're writing code because there's no checking of types or anything. JavaScript doesn't have any objects really, or like real objects, classes with access modifiers and so on. TypeScript adds that for us. So there's a lot of stuff that TypeScript adds to the game that was broken in JavaScript. And it looks to me, it's still early on, but it feels like the community is moving away from JavaScript toward TypeScript. Can it fix JavaScript's weird equality operators? Well, no, actually it inherited those. It's a little cleaner, but yeah, you can talk about memes, Andrew. You can find tons of memes about weird JavaScript stuff. Yeah, so we looks like we're migrating away from JavaScript toward TypeScript, but it's probably going to be 5 or 6 years before that transition is complete, only because TypeScript is a much more robust language. It's a lot safer too. Yeah, you can still screw stuff up in TypeScript for sure. Ryan Dahl, the guy who wrote Node, came out with a new project a year and a half ago called Dino. Node and Dino, it's an anagram, right? But Node is all TypeScript and Dino is all Node is JavaScript and Dino is TypeScript. So even Ryan Dahl, the talk he gave at, I can't remember which conference he was at, it was about a year or so ago, but it was my regrets. It was all this stuff that he regretted in Node and the way he was fixing all those regrets by moving to TypeScript instead. The downside is that TypeScript currently is transpiled. So we transpile the TypeScript into JavaScript. Currently, there's no native TypeScript engine in any of the browsers that I know of. Maybe Chrome's got some experimental stuff, but it all gets transpiled into JavaScript. At least it happens prior to execution, so it's not like the Python version where you're sort of doing it on the fly. Here you write in TypeScript, it gets crunched down to JavaScript, and the JavaScript gets sent to the browser. We'll fix that too. Once we've got a native TypeScript backend in Dino, then we'll start working on they'll start working on native browser engines for for TypeScript on the front end. Right now, everyone is dependent on Google because all of the browsers, doesn't matter who makes it, even Microsoft, they're all using Google's V8 JavaScript engine to run front end stuff. And presumably, if there's a TypeScript engine, it wouldn't be under control of Google. It'd probably be under control of Microsoft because Microsoft is sponsoring TypeScript projects. Speaking of the evil empire, did you see that Microsoft is bidding to buy Discord? If you guys are smart, you'll just skip 4.11 altogether and spend all of your time writing a Discord replacement, because once Microsoft buys it, there's going to be this mass exodus and everyone will be looking for a new platform, right? So build a couple of Discord clones and all you really need is good marketing to get the word out. I know, it was a bunch of money too. It's like 10 billion or some crazy $1 billion. Why? I don't know. And Slack apparently has reinvented email. Slack is now saying, oh, you can send a message to anyone who uses Slack. It's like, yeah, I could do that right now with email too. I was like, we're all saying Microsoft with an asterisk now. Too funny. I mean, the same thing happened when Microsoft bought GitHub and people panicked, right? It all sort of calmed down. I still think about it. We'll use GitLab in most of our courses. Yeah, open source. All right, so let's get back to some TypeScript here. So here's an application. Let me just run it. Where can I stick this and not be in the way? Nowhere. Let's just run this English server. Reason ML. Yeah, Yuval, I've never heard of it. What's the application? It sounds like a machine language, machine learning sort of thing. Let's go find out. Oh my God, the Zoom thing just kills me. Oh, based on Camel, what could go wrong? You know, I guess, but you know, at some point, like, can we just please stop coming up with new languages? I mean, for God's sakes, the computer can only do a certain number of things. They're all running on the same CPU, right? These CPUs got a fixed set of instructions. Why do we have to have 100 different languages? Like this looks exactly like other, it looks like TypeScript to me. Like why do I have to have something else that looks like JavaScript or TypeScript? Ah, I wish we only had like 2 languages, one for front end, one for back end, maybe even just one language, just assembly everywhere, assembly language, and that's all you get. And enjoy it. Yeah, I guess it's capitalism. Yeah, the front end frameworks too. It's like, which one are you going to use? There's 40 of them, right? You here's the answer. You use the one your boss likes. And it's sort of the corollary to happy wife, happy life. No, I don't know anything about Reason ML. And unless they have like really good swag or something at a conference, I probably won't pay any attention to it. All right, so here's a little, this is an Angular app. Let me just show you what it does first, and I'll show you how it does it. So here's the app. It's real fancy. I'm not a front end guy, like a UI developer, clearly. I think this is the second UI you've seen. And they looked exactly the same, right? It's like big black text and a big button. That's kind of, that's the breadth of my front end design experience. Oh, new messages. The swag, yeah. So here's the timer, start numbers. So I click this, what happens? 1, 2, 3, 4, etc. Yeah, it's a mobile UI. It works on mobile and desktop. So here's a little timer that's happening. No errors on that one. And actually, there's probably some stuff happening in the console too. I usually write stuff to the console. Let's see, clear filters. Undefined not an object, sweet. But at least it's writing the current timer to the console. That's fun. So that's a little timer. And then here's an API call, calling a weather API. It's calling it from the front end, which you do not want to do. Do not make any API calls outside of your own backend from the front end. But if I just click get weather, now I get there's current temperature, 51C. Holy shit. Where is it 51C? Maybe I'd probably just put the wrong label on it. It's like, oh, this is the temperature on Venus. All right, so that's what it does. So it's got this little timer that runs. I can click get weather. It'll go display the weather. Did you notice though, let me just refresh this page. So did you notice that every time I did something, so I did start numbers, I did get weather, like the page did not refresh, right? It's just new data just appeared. And that's kind of the thing with these front-end frameworks. I'm not refreshing the page. That's the single page application aspect of this. All right, let's go look at some source. So the thing with all of these, well, actually the thing with Angular, I'm not sure, actually React is a little cleaner, but with Angular for sure, you get a whole bunch of files. Like if I just build a simple project, I'll get like 100 files. There's only 2 or 3 that we're really interested in, but it can be intimidating when you see all this stuff like, holy crow, like, you know, what's this? What's, you know, there's polyfills, like, what are those? I don't know. Like just all this stuff. You don't have to deal with it really. All we're really interested in is kind of the core stuff. And we have to write that. The automated framework building tools that we use will give us, it'll give us a page, but really with nothing on it. And so we've got to go and start filling stuff in. That said, like when I start up with a framework like Angular, what I usually tell folks to do is something like this, like new project. Let's do an Angular CLI project, call this Invisible or something. It's Angular, cool. So I'll create this in a new window. It's going to go off and load a whole bunch of stuff for me. Angular uses the same sort of Node package manager that Node does. So it's grabbing a bunch of stuff, all of their dependencies, and installing them for us. And my advice on new projects is to just start simple. So like here's this new project, right? All I've got in the source folder, I've got an index.html. Just start there. Like look at that. It's like, oh, what does that mean? How can I change that index.html file to do something? And I'll notice, oh, let's see, on this here I got this weird tag, approot. Like, what's that? Where does that live? Go find that. It's going to be here in app. Approot is in app component. And just change one thing. Like here, it's got the title, Bazibel. Like just change that and rerun it and see what happens. Or here's the HTML for this page. It's actually a really huge freaking page, the little demo that they give you. But it's got a lot of stuff in it. So it's got drop-down menus, it's got functions that run on a click, like tons of stuff here. Just look at that running page and decide to change one thing, go change that thing and then examine what happened. That's how I learn new technologies. I just start really slow and just start changing one thing at a time. And by the way, just change one thing at a time. Same as debugging, right? Because if you change two things, which one fixed it? I don't know. I changed two things in here. Which one made that thing show up on the page? I don't know. I changed two things. Now every time I got to change both things? I don't think so. Did it finally finish? Yes, finally. Now it's indexing it. My poor machine sounds like it's going to take off. So that's my approach. Like this page that we're looking at here is this fancy little, it's their Tour of Heroes application, I think, but it demonstrates a whole bunch of stuff that's really, really interesting. So it's worth taking a look at if you're thinking about Angular. Let's kill that. And we're back here. And sweet. Back to where we were. All right, let's take a look at this really quickly. I'll just give you a really quick romp through Angular. Don't know how long this will take, but I'll give you the highlights at least. So we look at that index.html. Index.html is the default file for a web server. If you just say http google.com, hit return, it's going to go find index.html at google.com. If you're on KidPub, you hit www.kidpub.com, return, it's going to find index.html on kidpub.com, at least the web server's document directory. So that's the default. We can use that to our advantage by putting in index.html. That's the thing that's going to show up when somebody opens our little app, like here. When I click that, that's index.html. And which means I can stick stuff in there, right? So what did I stick in here? I stuck in, like this is just straight HTML, except for that. This little approot tag, like that's not HTML at all. That's how Angular works. In Angular, I think it's called Angular because of the angle tags, right? The gangsta tags. In Angular, we can define our own HTML tags. We can define our own tags. For example, this one. And the way it works is Angular plugs into the document event handling model in the browser. And so as the page is rendering in the browser, it gets to this thing and says, holy crow, what's that? Well, Angular has hooked into that system of, oh, this is a paragraph, I'm going to display it this way. So now it says, oh, this is an approot tag, like, well, what am I going to do? Angular takes over and says, here's what you're going to do there, and then returns to the regular page rendering. So this is defined somewhere. This is defined in a component file. So the notion in Angular is I've got a whole bunch of components. Each component does something, and I can put those components together on a page to do whatever I want, to build an application. Here I've got one tag defined called approot. It's going to be defined over here in app component, the TypeScript file. And you see it right here. Selector is the way we create that new tag. So that means anytime I see approot that looks like an HTML tag, this is what goes in there. What goes in there is the template URL. So this thing, app-component.html, gets plugged in right there. It gets plugged in. Now let's go see what's in there. App-component.html. Oh, look at this. Current timer, errors. We saw that already, right? That was over here. Current timer, errors, and so on. That's that component. But then within that component, I've got a child component. I've got a new tag defined called app calling HTTP. We'll get to that in a sec. Let's look at some of this other stuff. This actually looks really similar to that little brackets thing we did, right? When I just plugged a function into a button click. Same idea here. I've got a button. This notation means that I'm going to send a signal out of the button called click. And when that occurs, this is the function handler for it, the event handler. So when somebody clicks, I'm going to run the start timer method. I'm in app-component.html, so that method's going to be over in app-component.typescript. Here it is. Here's my start timer. So that came from this button click, run start timer. There it is. And what does it do? It does, how does it do this? Timer value. Timer, oh, this one's a subscription. So what's happening here is, make this bigger for you. Stop it. Yeah. It's over here so we can see it. So this is a little like deeper into TypeScript than we're going to get into here today. I'm creating something called a subscribable here. It's the, remember we talked about pub sub when we looked at architectures, publish subscribe. That's what this is. So I'm essentially setting up a publisher. The publisher is going to do this. It's going to create what's called an observable from this array of numbers. And then it's going to, every 1 second, it's going to push out a new number, basically. As a starting timer does. So the idea in Angular is that we have a pub sub kind of system with observables. We've got some observable that is generating data periodically, and then we have an observer that's watching for that. And when new data shows up from the observable, the observer is notified, and then we can just update the page with the new value. It's the subscribe here. So I've got a timer observer. It's going to be watching the timer. And just as we said in the architecture discussion, I've got a subscribe method. I'm passing timer options in for this to tell it which timer I want. But I'm going to subscribe to this timer. When it changes, the observer gets notified. And it doesn't have to do anything. It can do whatever it wants. What it does, though, is every time there's a new value, so on the next new value, it's going to log it. And then it sets the current timer value to the value that came out of the timer. Well, what's current timer value? Where do we see that? I don't see it anywhere here. Oh, here it is. So this notation, this double mustache notation, oh, I'm sorry, you've had a question. How do I share state between two distinct components? Yuval, there's two mechanisms. If it's a child-parent relationship, the parent can send data down to the child just through inheritance. It ends up looking like inheritance. If I'm going the other direction and I need to get data from a child component up to a parent component, I need to use a signal. So I can set up a signal handler for it and then emit values out of the child. If I've got two components that are unrelated to one another, I can use the same thing. I can set up a signal, an event handler in one of them, and then emit those signals on the other one. It'll catch those. So the short answer is we'll use signals to send data back and forth between the components. And there's an edge case where, actually is the base case where I've got a parent-child relationship. It's just much easier to go parent to child. This double mustache notation. What this means is that double bracket thing says, hey, this is a variable. I want to show the current value of it. Anytime it changes on the backside, so anytime this happens, the observable has emitted a new number, I'm going to grab it, and just all I'm going to do is set a variable to that new value. When that occurs, there's an event that happens, basically an update event, and this piece just plugs in the new value. That's why on the page that you start numbers, that's why here, that's the current value of the timer. 2, 3, 4, and so on. Every time it emits a new value, the next function gets called. This guy gets called, this one. And then I just update the variable. If there's an error of some sort, it'll log it, and I've got this current timer error variable. That's going to show up here on the errors paragraph or whatever it is. So most of this code is all around the time. In fact, all of this code is around the timer. There's nothing else in here but a timer. So you can see there's a lot of code to do it, but like I have really fine control over what's happening to that data and when. I can make a decision here in this next thing. I could defer writing it to the page if I needed to, or modify it in some way. At that point, it's just a variable that I received from some service. All right, so that's sort of a subscription kind of thing. Let's talk about this tag. So that handles all of that. How about this tag, app calling HTTP? Like, where is that defined? Let's go back here. Well, it's not in here anywhere, right? Must be in the project somewhere. Where did I put? Oh, here you go, calling HTTP. I just named them similarly so I could find them really easily. So here is, in here, I'm plugging in app calling HTTP. That's going to be over here. Sure enough, there's a selector. So that means I'm defining that new tag right here. And the template for it is in calling HTTP component.html. It's this. And then if you look at this stuff, that is this, right? Calling HTTP from a service. So all of that came from this little bit of HTML. And you're starting to see, I think, that we really are componentizing this. We're making little chunks of code that are more or less independent from one another, but then we can place those chunks on the page like wherever we want to. And if I wanted to get fancy, I'd use CSS for this, maybe a framework like Bootstrap or something, or actually Angular's got something called Angular elements that look really nice. So I could use those. So I could arrange it nicely on the page so it all sort of made logical sense. Same thing here though, right? So here's the calling HTTP thing. It also has a button that I'm going to capture the click event. When somebody clicks that button, we'll run a function. The function is get weather. And then here I'm going to just display those variables. So current weather and pressure, so temperature and pressure. There's nothing in those right now, so I'm not going to see anything. Should I see anything? I don't. No, I don't see the C on temperature. Did I set that up to hide it? I don't remember. Component, index. All right, so here is this is where the service comes from, so the weather stuff. All right, one component right here. I'm going to have a service called weather service. Now that weather service is basically an HTTP service that's going to call a backend, a third-party API in this case, to grab some weather for me. I'm going to inject it into this component. The injection happens in the constructor right there. So when I say, oh, give me a weather service, I'm going to call it weather service. That gets injected into this component. It's kind of a subtle, kind of weird thing. Like often you would just, like in Java or something, I just create an instance of it, right? I would go and get a new weather service object and hold a pointer, a reference to it in my code. In injecting, I sort of decouple that. So it's not the code's responsibility anymore to figure out how to get that service. Instead, I put the work on the service itself. So the service knows how to configure itself. And then when I need that service, I just inject it into the component this way. The nice thing about this is that now my code here, all it has to do is just use the service. I don't have to really configure it, or all that's done in the service itself. And if I needed to change like the service part of it, I would change it here in weather service. We'll see there's code for that. There's a class called weather service. I would change it over there. This code probably wouldn't change because I just, modified something in the service. All right, here is the app component, this one. Here's the button. Get weather is going to be run when I click the button. Get weather's over here, that function. And actually, like, this is really simple on this side, right? So when somebody clicks that button, I'm going to just go to the weather service. It's got a method called get weather, and it's set up as an observable. So I can subscribe to it. Anytime that get weather service responds with some data, I'm going to run this little bit of code in the next stanza. So next means, hey, I just got some new data from the subscription. That'll run anytime new data shows up from the subscription. And it doesn't do very much. In fact, it really just does the same thing the timer did, right? It takes that current weather variable, this one, current weather, and it sets it to the response. Response.current has the current weather for me. That came from the weather service. In fact, it came right there. So when next gets called, these are function calls in TypeScript. So that means I'm receiving, that's a parameter coming in from the weather service called response. And it is of type weather. Let's go look at the service. The service is probably going to be, actually put them in a services folder. Here it is. Here's the service. So we injected it here, right? There's our weather service. And then we're using it down here. And here is the actual service. Here's the service. In Angular, we have to mark it injectable if we're going to inject it in the way that we just used. So that's why this injectable is up here. I'm going to use the HTTP client because I'm going to make an HTTP call. And what do I get? I inject the HTTP client so we can use it. Locally, it's going to be called HTTP. And then here's get weather. So this is the function that was called, where's our guy? This guy. So get weather on the component. Here's the component. Here's the component. Here's get weather. And it's just going to run this. And so here's the service again. So this function gets run. It's an observable, which means it has the ability to emit values periodically. Now, in this case, in the case of HTTP, there is no next value really. So I'm going to make a call back to some API. And then when that result comes back, that's kind of the only data I have. I'm not going to make a second call in this case. I just have one call. So I'm going to use an observable for it because it's simple and allows me to defer. I don't have to wait for the data. I just say, hey, when it shows up, let me know. So I'm going to use observable in that way. And as far as I know, it's sort of the current paradigm. My guess is at some point we'll have a special HTTP kind of object that implements sort of an observable kind of interface. But look at all it does. So it goes out and does HTTP get. And then where are we going? We're going to this weather config place. Weather config is up in the configs directory here. So this is the base URL. Looks like we're going to openweathermap.org. I've got a key for it. And I just hard coded a bunch of stuff here. Latin lon, 4198, 732. Looks like Boston-ish. Excuse me. So I'm going to use those things within the context of the service. So do a get on that URL, throw the key in there, and then the options are options that I'm going to send to the API. These are the it's the way I want to see stuff. So I want to see how is this working? That's the get. Yeah, I guess it's really, these are options on the HTTP call. And it's telling me that the thing I'm interested in is the body coming back. So apparently from that URL, I'm getting some stuff back that I don't care about. I'm really only interested in the body of the response, which is fine. And it's going to be in JSON format is what this is telling me. All right, so I make the call. And actually this call like sort of encapsulates what's happening on the front end. I'm making a call to an API. In your case, for your projects, it's going to end up being your backend API stuff. Like, when is that going to return? We just don't know, right? Like, how long is it going to take? Could take a millisecond, could take 10 seconds, like, just who knows? Well, the thing on a browser is, like, if I wait for something, if I click the button, and then I've got to wait for the response to come back and then display it, JavaScript only has one thread of execution. It is single threaded. And that means that if I'm going, I click the button, and now I'm waiting for the response to come back, there's only one thread. If I wait, everything waits on the page. You wouldn't be able to scroll. You wouldn't be able to click any buttons. Like, nothing would happen. The page would just lock up while you were waiting for this response to come back. And so instead, JavaScript, when it sees something like this, oh, I'm making a blocking call, I'm making a network call to an HTTP server, it just says, oh, that's going to block. We'll just keep going. So it does make the call. It makes the HTTP call, but then it just keeps on going to the next line of code. The upshot in JavaScript and TypeScript is that you're not guaranteed when you execute a line of code that's returning a result, you're not guaranteed that result is going to be there on the very next line of code. It probably isn't, in fact. So we've got to, like, there are ways to write around that asynchronously. So I can make the call and then just go away, do something else. And when that does come back from the weather service, in this case, be notified of it and pick up where I left off and keep going from that point. So JavaScript is a single-threaded, non-blocking, asynchronously running language. And TypeScript, because it's basically JavaScript, is the same. They're both asynchronous. I think it's the fun part of JavaScript. It takes a while to get your head around it, like to really understand what's happening behind the scenes. But once you get it, it's like this really cool environment where there's just stuff happening all over the place in random orders, it feels like. But it's like juggling. You got all these things in the air. Eventually, they all end up in your hand. Now you can keep going. It's a really, really cool way to write code. As far as I know, at least that I've run into, it's kind of the only, code platform that does that. I haven't run into any other asynchronous kinds of languages like that. Why am I dinging? I'm dinging because, oh, no kidding, it's my landscaper. I was just talking about him yesterday. Get some work for him. He must be like monitoring my Alexa or something. That's creepy. All right, so that's what's happening with get weather. I'm going to make an asynchronous call to some backend. In this case, it's a third party. In your case, it's going to be your own backend. And then when it comes back, because this is an observable, and here I subscribed to it, when that response does come back, this guy gets notified. The response is passed in this variable, and then all I have to do is just set the response. It magically appears on the page because this is a single page app. So there's the round trip. Here's get weather. Yep. Now it's 53C. I'm going to change that to an F. It's making me crazy. There we go. Save that. Now I just changed HTML, so I don't really have to change I don't have to change the, I don't have to restart the browser. We do have to reload it. 53F, that sounds a lot closer, right? It's 55. It was supposed to be 70 today. Like, where is that? We were misled. All right, let's see if there's anything else in here that's interesting to us. Assets, blah, blah, blah. Yeah, I'll just mention this because I'm looking at it. You probably won't have to deal with this, but just so you know what the name is, it's a good thing to know for interviews. There's these polyfills down here. Actually, there aren't many. There aren't any, in fact. That's cool. A polyfill is to take care of browser inconsistencies. So browsers, let's just take a look at something like Fidelity. Fidelity. So we look here and do a show source. Look at what's at the top of this HTML page. This stuff. It's really just, it's Microsoft that caused this issue really early on in the development of the web. I'm talking like 97, 98-ish, I guess it would have been. Microsoft started diverging from the HTML spec by adding their own stuff that was incompatible with everyone else's browser. They did it to differentiate themselves in the market because they wanted everyone to be on Internet Explorer. What it ended up doing was splintering the HTML browser industry. And so companies everywhere, this is on Fidelity, companies everywhere started having to do this. If this browser, it's IE and it's less than version 7, then I got to do stuff like this. If it is version 7, I got to do it this way. If it's version 8, I got to do it this way. If it's version 9, I got to do it this way, so on. You have to take care of all of these weird browser incompatibilities. Some folks just don't care. Like on my sites, when I build sites, it's like, hey, if you're not using Safari, screw you. Like, it looks great in Safari. I'm not even going to test it in Internet Explorer or Edge or the devil it is these days. I don't care. Fidelity, clearly they care still. This used to be a much, much larger list. And God, I remember going down into the QA group over on Summer Street. And it was just basically a big, big room on one floor of this Fidelity office building. And they had like 50 or 60 workstations set up. This is before we had virtualization technologies. So they had 50 or 60 workstations set up, and every single one of them was a different browser and operating system. So they had like Windows, 6 or whatever the devil it was, and 9 different browsers on Windows 6, all lined up. They would test all of their pages on all of the browsers, Netscape, Opera, Mozilla, all of them. And at some point, I was there when they did this. At some point, they said, holy crow, we're spending just a ton of money on QA for all these stupid browser incompatibilities. And they just drew a line in the sand and they said, hey, if you're not using IE, or I think Mozilla was the other one, like, good luck, was what they said. And this was like a messaging that went out to customers. I was there when we did this. So we sent out the message to all the customers. We put the badge on the website that said best viewed in Internet Explorer, and just never looked back. And I think they saved a ton of money by not QAing all the various browsers. So that said, like, even within the browser world themselves, there are different versions of the browser, and each browser implements JavaScript slightly differently. So let's see if I can find one really quick, browser. JavaScript capabilities, compatibility. You end up with stuff that looks like this. Oh, this is a tiny one. Hang on, let me find a bigger one. And of course, I can only find one. That's really, here's one. Yeah, it sucks too. But basically you end up with charts like this. Browser compatibility chart. Let's try this. That's a little better. Yeah. It's taking way longer than I hoped it would take. Clearly I should just preload this next time. I'll just look at one. It's like, and the real list that I can't find, it's probably on MDN, the Mozilla Developer Network. It's just this massive table with hundreds and hundreds and hundreds of rows, and all of the browsers and all of their versions across the top. There is no set of browsers that does everything the same. And so we have to take care that when we're writing functions, especially, I'm writing functions that are going to run in JavaScript in the browser. JavaScript runs in the browser. So I've got to make sure that those functions will work properly in the browser. If I notice that, oh, you know, the thing I'm interested in doing isn't on the compatibility chart, it uses, I wish I could find the thing I'm looking for. I'm going to give up. If you've used a function or, you know, like some layout thing, or there's just something that is different among browsers that you know you're going to deploy to, you end up putting them in this file called polyfills. And what polyfills does is it looks for stuff that's incompatible. And when it sees one, it looks in this polyfills file and matches up a function that will be compatible. So it's a way to supply code that will run in a browser that wouldn't normally run a function that you'd written. I can sort of patch it up, or I can, you know, make it work sort of using a polyfill to do that. Or maybe there's a feature that's entirely missing in that browser, and I've got to supply it here on the polyfills. So that's what a polyfill is. Polyfill comes from, it's the stuff you stick in pillows. You know, you stuff a pillow with this sort of cottony kind of acrylic sort of stuff. You just jam it in the pillow, that's a polyfill. So here we're just sort of jamming stuff into this bag and hoping the browser does the right thing. That was a lot more than I wanted to talk about polyfills. I thought that was going to be like a 30-second discussion. Anyway, that's what a polyfill is. All the rest of this stuff, a lot of it is around testing. So I can test all this code very easily, front end and back end. So there's a lot of test stuff. Like here's test.ts. This is my top end test. I can run tests from here. Did I actually do any tests in here? Doesn't look like I did. Anything in assets? No. I didn't write any tests for this one. All this gets compiled down to JavaScript, and then we ship it to the browser, and that's the application. Any questions so far? You know, I'll be honest with you, it looks like a lot. Like there's a lot of pieces here, a lot of moving parts. However, the thing to do, and you're all going to have to do it, well, all the teams are going to have to do it because you're going to have JavaScript somewhere on the front end making calls into a back end. The way to do it is start slow with a demo app, and as I said, just change stuff. In fact, I would go to the Tour of Heroes, Angular Tour of Heroes. If you go to angular.io, it should be right on the top page. Tour of Heroes. It's a really, really good tutorial, and it does it really simply. So, you know, it does it just a little bit at a time. So by the time that you get through it, you've got some really solid Angular chops, but it hasn't been overwhelming. You've sort of learned it as you go. Components. This site is just really well written. They did a nice job on this. All right, guys, that is all I've got for Angular. I just wanted to just show you a little bit of it, kind of what it looks like, and start talking about like how you might use Angular on the front end for your stuff. Again, you don't have to use Angular. You can use React, like something, but you're going to need some JavaScript on the front end, whether it's a framework or just straight JavaScript with like jQuery stuff. It's kind of up to you. I would recommend a framework, either Angular or React. I think is probably the way to go. Those are the two biggies right now. Where's the best way to learn JavaScript? Anastasia asks. Tutorials for JavaScript. I'm thinking. Actually, yeah, here's what you need. For JavaScript, there's a great series called You Don't Know JavaScript. It's a set of free books. So go look for You Don't Know JavaScript, KJS. The books are on GitHub. They're really well written, and they start out, there's a set of them. There's 5 or 6 books. Like one of them covers observables. The first one in the series is Eloquent.js, Andy says is good. The first one in the You Don't Know JavaScript series kind of brings you up to speed. In fact, I think it's called Up to Speed. It assumes you know another language. So it sort of compares and contrasts JavaScript against other languages. But, you know, that's probably a day's worth of work to get through that one. And Andy, I'll look at Eloquent.js because I get asked that question a lot. Or you can come to my CS412 class in the summer. All right, guys, that's all I got. I got 90 seconds left. Hey, have a really, really nice weekend. It should be fairly nice, relatively speaking. Yeah, have a good one. I'll talk to you on Tuesday. Bye, everybody.
Thank you, Professor.
Y'all. Oh, y'all.